which is 3217 delete nodes from linked list present in array. So you're given an array of integers nums, which contains the numbers that you should remove from the linked list and the head of a linked list. So we should return the head of a modified linked list after removing all instances of uh, every item in the array nums and return the new head of the linked list. So in the first example, we have nums area 1, 2, 3. So this means that if we see 1, 2, and 3 in the linked list, we remove all instances of 1, 2, and 3 from the linked list. So the linked list here is 1, 2, 3, 4, 5. So we take out 1, 2, 3, and the new head is 4, and it points to 5. In the second example here, we notice that the nums to remove is just 1, and the linked list is as such. It goes from 1 to 2 to 1 to 2 to 1 to 2. So we should remove all instances of 1 from the linked list and return the new linked list with its head being 2 and pointing to 2 and 2. As you can see, all 1s have been removed. In the third example below, the numbers array just has one element, which is 5, and the linked list does not have 5 in it. So we just return the original linked list head. So how can we solve this problem? So to check whether a number needs to be removed or not, an easy way to do it with O1 lookup time will be putting it in a set. So as you can see here, I make the nums array a set, so it's for faster lookup time. And the first thing you need to do, for example, let's look at example 1, right? So we need to make sure that the first element in our new head is not something that needs to be removed. So I'll have this while loop here, so which checks that if the head value is to be removed, we move the head pointer to head point next. So pretty much we're removing the head and assigning the next value to head to be head. So this will ensure that the new head is a value that does not need to be removed. After that is done, then we need to set up two values. One is previous, another one is node. Here we notice that the head value after the while loop here has been completed will definitely start with a head that does not need to be removed. So we set that to be previous, and the node in this line is going to be the next node.next, head.next of the previous, right? So then we have our while loop here. So we need to go until the end of the array, end of the linked list. So that would mean that at some point in time, node will become none or null as the linked list ends. So we have our while loop with the condition while node, and so we have to check if the node's current value is to be removed, and if it is removed, we look at the previous value, which is a node before it, and we set the next value of the previous node to be previous.next of next. So what we're pretty much doing is just skipping the current node's value if its value is in the set that is to be removed. And we also need to point node to node.next to proceed on into the while loop. By the end of this, the previous will still remain the same, but the node has changed as we're skipping the current node. We look at the else condition, which is the case where the current node does not need to be removed, as in it is not in the set of numbers. Then we just move both pointers forward, as we do not need to remove this node at all. So previous becomes the current node and node becomes node.next. And by the end of this operation, all the nodes that need to be removed would have been removed. After that has been done, then we simply return head, which will be the head of the new linked list. So let's look at the time complexity of this question. So we have one while loop. It's possible that this could go all the way till the end. So it could be on. The main loop here is also going to be an on operation, as we do not. So we only iterate through the linked list one time. And as for space complexity, we have a set here, and it's going to be of size O of n, assuming that, let's say in the worst case, all the numbers are unique, right? So So that's the end of today's question. Thanks for watching.